So winter is coming, which means the days are getting shorter, the weather is getting worse, and therefore so is the performance of my solar panels. And so today I'm going to try to improve the efficiency of these solar panels so that hopefully we can get some better production out of them during the cold months. Now what I'm going to do is I'm going to replace one of my solar charge controllers. So if you don't know what a charge controller is, if you're using solar panels to charge a battery, which is what I'm doing, there is a little device that sits between the solar panel and the battery, and that's a charge controller. And its primary function is to make sure that the battery doesn't get overcharged when it's full. So in its simplest form, a charge controller is nothing more than a switch that disconnects the solar panel when the battery is fully charged. That's all there is to it. And that's a type of charge controller that I'm using right now, mostly because it's just really cheap. But the problem with this type of charge controller is that your solar panel is not operating at its maximum efficiency. And the reason for that is that the solar panel is always running at the same voltage as your battery, because it's directly connected to the battery, at least when the switch is closed, right? So if the battery is 12 volts, then the solar panel will also be running at 12 volts. But that's usually not an optimal voltage for the solar panel to be operating at. So, for instance, one of my solar panels reaches peak efficiency at around 18 volts. And that voltage is relatively constant for different amounts of sunlight hitting the panel. It might change a little bit depending on how much light there is, but not that much. So on a very cloudy day it might be 17 or 16 volts, but it won't be anywhere close to 12 volts, which is what the solar panel is running at right now. So what we need to overcome this problem is a charge controller that can actually have a different voltage on its input than on its output, so that the output can be at 12 volts, right, connected to the battery, while the input can be kept at around 18 volts, so that the solar panel can operate at peak efficiency. And that's exactly what I've made right here. So this is a new charge controller that I've built. The solar panel connects on this side, the battery connects on this side, and what this is going to do is it'll maintain 18 volts on the solar panel side and whatever the battery's voltage is on this side. So the way this works is this device is constantly monitoring the voltage on the input, which is the solar panel's voltage, right? And then what it'll do is if that voltage is too high, which means more than 18, it'll draw some more current from the solar panel, increasing the load, and therefore the voltage will drop down a bit towards 18 volts. And if the voltage is below 18 volts, so the voltage is too low, then this device will draw a little bit less current from the solar panel so that the load becomes lighter and the voltage will climb back up. And that way it constantly keeps adjusting how much current it draws from the solar panel to keep that voltage as close to 18 as it possibly can. Now, if you want to know exactly how this thing works to a component level, or maybe you even want to build one of these yourself, I'm going to put a circuit diagram and the code that's running on it on my website so you can have a go at this stuff yourself. So right now, what I think it's time to do is actually wire this thing up and see how much of an improvement it gives us over the old dumb charge controller. Okay, so we've come into the shed with our new charge controller, and now it's time to find out if this thing actually works. So right here we've got a cable that is connected to a big 12 volt battery, and over here we've got a cable that is connected to one of my solar panels outside. So what I'm going to do first is I'm going to connect the solar panel directly to the battery, which simulates one of my old charge controllers. And then we're going to measure the charging current that puts into our battery. After that, we're going to connect the solar panel to our new charge controller, wire that one up to the battery, and hopefully we're going to see that it's producing more charging current and therefore more power. So let's just start by plugging the solar panel into the battery, like so. Just going to turn this current clamp on, set it to DC, 0. Make sure the wire's plugged in. There you go. We're producing about 1.3 amps of current. Alright. So now let's plug in the new charge controller. just like that. Then connect this end to the battery, like so. Wait for this LED to turn on. There you go. Now it's in charging mode. Now before we're going to measure the charging current, what I would like to know is if it's actually regulating the solar panel's voltage to about 18 volts as we intended. We're just going to grab this multimeter, set that to voltage, and I'm just going to probe the input voltage right here to see if that's actually around 18. So there we go. 16.8, 17.4, and now we're at around 18.7, 18. Yeah, so it's a little bit on the high side. It's a bit above 18, but actually the optimal voltage was 18.3, wasn't it? So maybe that's actually a good thing. Anyway, the point is it's close enough. Right, so now let's measure the charging current. Here we go. Turn this on. DC, 0. And we're producing, there you go, about 1.5 amps. That is really not bad. That is a significant improvement, right? So let's just do the maths real quick, okay? So here we go. We have about 1.5 amps. Just grabbing my calculator here. So we have about 1500 milliamps. Before we had about 1300 milliamps, so we do minus 1300. That's a... I can't believe I just used the calculator for this. Anyway, that's an improvement of about 200 milliamps, right? So if we take that original 1300, so we say 200 milliamps divided by 1300 times by 100, that means we have about a 15% improvement over the situation without the new charge controller. So that's not too bad. 15% more power from the solar panel using basically a bunch of free components, because I already had this stuff laying around anyway. And even if you had to buy these components, it wouldn't be that expensive compared to an actual, proper charge controller that you would buy. But of course you do have to assemble it yourself, so I guess that will, if you count the hours, it's still an expensive product. So now I just need to go ahead and install this thing in the electrical box upstairs, but I won't be bothering you with that today because, to be honest, it's kind of boring, and I'm also not quite sure how I'm going to do it just yet. I might need to drill some extra mounting holes in this or whatever. I'm not too sure about that. But anyway, I hope you've enjoyed this video, and of course, thank you for watching.